Penguins are truly bizarre creatures, from having a mouth that looks like something straight out of Pennywise, from the Welcome to Derry series, to swimming at torpedo-like speeds, and even the fact that the males can produce milk to feed their young. Why did Mother Nature create such a strange being? Let's dive into the fascinating details of every aspect. The mouth of madness, like IT's mouth. If you're used to the image of chubby, adorable penguins waddling across the ice in animated movies, brace yourself for a biological reality check that's straight up shocking. Hidden behind that innocent exterior is one of the most terrifying oral designs in the entire bird kingdom. When a penguin opens its beak, you won't find a smooth surface or a soft tongue. Instead, you're confronted with a labyrinth of razor-sharp spikes, transforming their beak into a literal death trap of punji stakes. Anatomically speaking, penguins, like all modern birds, are completely toothless. However, nature has compensated for this with a specialized system called papillae, or fleshy spikes. These aren't soft, feathery bristles. They are structures made of keratin, the same tough protein that makes up your fingernails and hair. These spikes grow in dense clusters across the entire surface of the tongue and the roof of the mouth, extending deep down into the esophagus. The kicker lies in the direction they grow. They don't point straight up, but are angled backward at a sharp 4-5 degree angle. This creates a mechanical process that is absolutely brutal. The moment a prey item like a fish or a squid is snapped up in that beak, any attempt to struggle or wiggle backward only causes these spikes to dig deeper into its body. Conversely, swallowing is incredibly smooth because the prey slides along the natural grain of the spikes. In the oceanic environment, penguins face an extreme physical challenge: their prey. Fish and squid are covered in a layer of mucus that makes them incredibly slippery. Imagine trying to grip a wet bar of soap with a pair of flat chopsticks. While swimming underwater at high speeds, that is exactly what a penguin is up against. Since they don't have hands to hold or teeth to chew, penguins need a deadlock system. Research data shows that the friction generated by these papillae is several times greater than that of a standard bird's tongue. This system operates like a one-way conveyor belt. With just a slight swallowing motion, the spikes work in perfect harmony to shuttle the prey straight into the stomach. No matter how strong the fish is, once it enters this matrix of needles, its physical chance of escape is exactly 0%. Every dive a penguin takes is a desperate race against time and oxygen. They don't have the luxury to chew or fiddle with their food. By owning a mouth packed with spikes, they slash prey processing time down to a minimum. It usually takes less than a single second to gulp down a small fish. But that's not all. This structure also doubles as a high-efficiency water filtration system. When a penguin snaps at prey underwater, a massive amount of seawater rushes into its beak. Those fleshy spikes act like a biological vice, locking the fish in place and allowing the penguin to purge the excess water through the sides of its beak without worrying about its dinner slipping away. It's an extreme bit of biological fine-tuning, turning the beak into a multi-tool that functions as a clamp, a sieve, and a primary esophagus all at once. The existence of this horror movie mouth is the ultimate proof that nature is willing to scrap every standard of aesthetics in favor of survival efficiency. Penguins might look clumsy and awkward on land, but underwater, they are elite assassins, armed to the teeth. Yet, believe it or not, this isn't even the strangest thing about them. Heavy and fast as a torpedo. If you were to pick up a bone from a seagull or an eagle, you'd notice it feels almost weightless. That's because those bones are hollowed out and packed with air sacs. A flat-out perfect design choice by evolution to keep weight down for flight. When it comes to penguins, they threw that playbook out the window. Their bones are dense and heavy, much more like what you'd find in a mammal, and in some spots, they're actually even denser than human bone. Now, you've got to wonder, why on earth would nature design a bird to be so heavy-set? Well, the answer is tucked away in Archimedes' principle and the whole physics of buoyancy. In physics, Archimedes' principle tells us that the upward buoyant force exerted on a body immersed in a fluid is equal to the weight of the fluid that the body displaces. Now, for your typical bird, with those hollow bones and a system of air sacs taking up 15 to 20% of their body volume, this buoyancy is a massive roadblock if they ever want to dive down. To plunge deep into the heart of the ocean, penguins have to beat this force. Those dense bones, with no hollow marrow, act exactly like a professional diver's lead weight belt. According to biological studies, a penguin's bone density is actually 30 to 50% higher than that of flying birds of a similar size. This helps them hit neutral buoyancy much faster, allowing them to sink naturally without burning through a ton of energy just flapping their wings against the water's upward push. But the weirdness doesn't stop with their skeleton. Just take a look at their wings. While the wings of other birds are a complex mix of flexible joints and long feathers designed to generate lift in the air, a penguin's wings have evolved into these rigid, flattened flippers. Anatomically speaking, the bones in a penguin's wing have shortened and flattened out, and the joints at the wrist and elbow are almost completely locked tight by incredibly tough connective tissues. This essentially turns the entire forelimb into a single, solid lever, a powerhouse of a mechanical structure that's physically impossible to fold. When they flap their wings underwater, they aren't swimming the way a fish or a seal does. They are literally flying through a medium that is roughly 800 times denser than air. Every single wing stroke generates a massive amount of thrust. Here is the kicker. While birds in the sky only generate power on the downstroke, penguins produce thrust on both the upstroke and the downstroke underwater, effectively optimizing 100% of their motion cycle. Their speed is a loud and clear testament to this. The Gentoo penguin can hit underwater speeds of up to 36 kilometers per hour. That's basically the speed of a light-duty torpedo. To pull this off, their chest muscles make up a whopping 25% of their total body weight, a massive muscular ratio dedicated entirely to the art of underwater flight. This is a brutal evolutionary trade-off and a prime example of natural selection at its peak. To become the ultimate underwater pilots, they forever slammed the door shut on the sky. Roughly 60 million years ago, their ancestors were still soaring through the air. But as the abundance of food at the bottom of the sea became the priority, their wings had to transform. Fluid dynamics research points out a harsh reality. A wing that is efficient for flying through the air and a wing that is efficient for deep diving are physically incompatible. You simply can't have both. Penguins chose the ocean, and the price they paid was that awkward, waddling gait we see on land. It's this heavy-duty build and flawless hydrodynamic design that allows them to pull off mind-blowing deep-sea dives. The emperor penguin, the heavyweight of the family, can plunge to depths of over 500 meters, about 1,600 feet. At that depth, the water pressure hits 50 atmospheres. That's basically like having a semi-truck crushing every single square inch of your body. To survive that kind of pressure, their rib cage isn't rigid. It's highly elastic, allowing their lungs to safely collapse to prevent air embolisms or tissue damage. On top of that, they have an incredible ability to store oxygen right in their muscles using a protein called myoglobin, with concentrations many times higher than ours, allowing them to hold their breath for over 20 minutes on a single dive. Every time you watch a penguin rocket through the deep blue, remember you're looking at a biological machine fine-tuned to the absolute extreme. They're living proof that nature is willing to tear up even its most successful blueprints to create a specialist that has no rival in a different environment. But have you ever wondered, in the bone-chilling cold of Antarctic waters which consistently hover around 1.9 degrees Celsius, the freezing point of salt water, how on earth a warm-blooded creature keeps its heart beating and those massive muscle groups from freezing solid? Every time you watch a penguin rocket through the deep blue, remember, you're looking at the living proof that nature is willing to tear up even its most successful blueprints to create a specialist that has no rival in a different environment. But have you ever wondered, in the bone-chilling cold of Antarctic waters, which consistently hover around 1.9 degrees Celsius, to the freezing point of salt water, how on earth a warm-blooded creature keeps its heart beating and those massive muscle groups from freezing solid? The defiers of the icy grave. Here's a fun, mind-bending paradox for you. In the world of biology, penguins aren't just afraid of the cold, they're actually terrified of overheating. To crack the code of surviving Antarctica's brutal temperatures, they've evolved a multi-layered biological armor that's so sophisticated, it puts our high-end wetsuits and designer parkas to shame. First off, let's talk about their feathers. Unlike most birds, which have feathers growing in specific rows or patches called terralae, leaving little bald spots of bare skin under their wings or on their bellies, penguins are covered head to toe in a dense, uniform quad. Their feather density is off the charts. We're talking up to 100 feathers per square inch. That's a crazy amount of insulation. These feathers aren't your typical soft, fluffy plumes either. They're short, stiff, and shaped like scales, overlapping tightly just like shingles on a roof or scale armor on a knight. This design creates an absolute barrier that keeps out the salty, freezing seawater, even when they're diving hundreds of meters down under crushing pressure. But the real magic happens right beneath those protective shingles. There's a layer of fine, long, incredibly soft down feathers that traps a pocket of dry air right against the skin. This trapped air is, hands down, the best insulator on the planet. It keeps their body heat locked in so effectively that penguins actually have to spread their wings or pant like dogs just to cool off after a serious workout underwater. In fact, when a penguin pops back up onto the ice, its skin is bone dry thanks to this high-tech waterproofing and air-trapping system. But the real secret that leaves scientists scratching their heads is actually their bare feet. Have you ever wondered why a penguin's feet don't freeze solid or get stuck to the ice, like a kid's tongue on a metal pole in the dead of winter? If that were us, the blood in our feet would chill instantly, leading to frostbite or even heart failure as that icy blood rushed back to our core. Penguins have hacked this problem using an incredibly sophisticated counter-current heat exchange system. It's brilliant. The arteries carrying warm blood from the heart around 3, 8, 30, 9 degrees Celsius down to the feet are tightly wrapped in a web of veins, bringing cold blood back up. As that warm blood travels down, it passes its heat over to the cold blood coming back up through the vessel walls. By the time the blood actually hits the feet, it's already been pre-cooled to just a few degrees above freezing. This genius move minimizes the temperature gap between the bird's feet and the ice, which keeps their precious energy from leaking out into the environment. On the flip side, the blood heading back to the body's core is pre-warmed before it ever hits the heart, keeping their internal temperature rock steady. Their feet stay just warm enough to keep from freezing, allowing them to stand on solid ice for months on end without a single problem. To top it all off, penguins are packing a layer of blubber under their skin that's about 2 to 3 centimeters thick. This fat isn't just a snack bar for those long stretches without food. It's the ultimate insulating pad, The combo of feathers, trapped air, and blubber creates a thermal seal so perfect that their body's heat radiation is almost zero. In fact, thermal imaging cameras often can't even spot a penguin against the snow because the surface of their feathers is nearly as cold as the outside air, while inside, their heart is still pumping away at a cozy 40 degrees Celsius. This is essentially a high-tech heating and energy conservation system that took humans thousands of years of studying thermodynamics to even begin to wrap our heads around. But here's the thing. Staying warm is only half the battle when you're living at the edge of the world. To hunt down schools of fish or red shrimp in the dim, murky shadows beneath several meters of thick ice, where sunlight is nothing more than a faint, ghostly blur, penguins need another heavy-hitting weapon in their arsenal. They need a pair of eyes that can pierce through the deep-sea mysteries and, at the same time, not be blinded by the soul-crushing glare of the Great White Continent. Legendary vision beyond imagination. To really wrap your head around why penguin eyes are so bizarre, you've got to look at our own eyes for a second. If you've ever tried to open your eyes underwater without goggles, you know the deal. Everything is a blurry, distorted mess. That's because the human cornea is dome-shaped, specifically engineered to refract light in the air. When you hit the water, which has a refractive index almost identical to the fluid inside your eyes, that focus just vanishes. We lose about 2/3 of our ability to converge light onto the retina. Penguins, however, went with a counterintuitive design. They have completely flat corneas. It allows light to travel straight into the eye without being bent the wrong way while the bird is diving deep. The result? Penguins have underwater vision so razor sharp. It's like they're wearing a pair of professional-grade Navy SEAL dive masks. This gives them the ultimate edge to spot tiny fish or microscopic krill in the pitch-black conditions, 200 to 300 meters down. But the real magic happens when they rocket back onto dry land. Normally, an eye optimized for the water would be hopelessly nearsighted in the air because of the sudden shift in refractive index. Yet, penguins possess an incredibly powerful and flexible iris muscle, the ciliary muscle that can reshape the internal lens with almost violent force. They can snap their focus in a split second, allowing them to spot a leopard seal stalking them on a distant ice floe the moment they finish a hunt in the deep, dark blue. And it doesn't stop there. A penguin's retina is packed with specialized cone and rod cells at an incredibly high density, allowing them to see a spectrum of colors that we are totally blind to, including ultraviolet light. This superpower is crucial for spotting prey with scales that reflect UV light, or picking out their soulmate in a massive crowd of tens of thousands of individuals that look identical to our human eyes. Even more impressive, penguins have a transparent nictitating membrane, basically a third eyelid. This membrane sweeps across the eye when they're swimming, acting like a built-in protective shield against salt and debris while letting light through perfectly. Another feature that leaves biologists absolutely floored is the pupil structure in certain species. For instance, the king penguin has pupils that can shrink down into a tiny, precise square when hit by the brutal glare of the sun reflecting off the white snow. This mechanism protects their sensitive retinas from getting fried, acting like a pair of high-end natural sunglasses. They literally possess a top-tier biological multifocal lens, allowing them to master two opposite worlds, the pitch-black shadows of the deep ocean and the blinding radiance of the icy continent. The evolution of the penguin eye is a masterclass in balance. If their cornea were too curved, they'd be blind underwater. If it were too flat, without that powerful focus adjustment, they'd be useless on land. However, beyond just spotting enemies and prey, there's a silent and far more dangerous challenge from the ocean itself that penguins face every single day: the massive salt concentration in seawater. This poison could destroy cellular systems and be fatal for any warm-blooded animal if it weren't for a chemical filtration plant hidden right inside their bodies. The ultimate desalination machine, the secret lies in an organ called the supraorbital gland. This is essentially a pair of specialized glands that act like auxiliary kidneys, but with a salt-stripping efficiency that is several times more powerful. The structure of this gland consists of countless tiny tubes surrounded by a dense network of capillaries. When a penguin consumes seawater, the salt concentration in its blood spikes, triggering an ion pump system within the gland cells. The supraorbital gland then actively pulls sodium and chloride ions out of the bloodstream and concentrates them into a briny solution that is way saltier than the ocean water itself. This super-concentrated salt solution is then funneled through small ducts and emptied directly into the nasal cavity. If you're lucky enough to catch a close-up of a penguin hanging out on an ice floe, you might see them give their head a vigorous shake or notice droplets of clear liquid flying from their beak. That's not a sign of a common cold or a random sneeze. That's the exact moment they're depressurizing the system, blasting excess salt out of their bodies to keep their blood electrolyte levels in the safe zone. Thanks to this biological mini-factory, penguins can drink seawater to survive their entire lives without ever needing to track down a single drop of fresh water. A legitimate superhero ability that allows them to completely own the ocean. However, a penguin's job isn't just about filtering salt for its own survival. These creatures are actually world-class bioengineers, playing a pivotal role in keeping the planet's nutrient cycle spinning. By consuming tons of fish and shrimp in the deep, remote reaches of the ocean, and then returning to land or ice shelves to relieve themselves, penguins pull off a massive migration of chemical elements. Their waste, scientifically known as guano, is one of the most nutrient-dense organic materials on Earth, packed with sky-high levels of nitrogen, phosphorus, and potassium. In the barren, icy deserts of Antarctica and sub-Antarctic islands, this guano is essentially white gold that fuels the entire coastal ecosystem. It provides the vital nutrients that allow mosses, lichens, and soil bacteria to thrive. Even when the waste washes back into the sea, it jump-starts the growth of phytoplankton, creating a perfect closed-loop food web. Researchers using satellite imagery have discovered that biodiversity around penguin colonies is often several times higher than in neighboring areas. They are the true orchestrators of energy flow from the ocean to the continent, ensuring that life in the harshest places on Earth doesn't just flicker out. But perhaps what really makes us tip our hats to penguins isn't their salt-filtering glands or their ability to fertilize a continent. It's their sheer willpower and social behaviors that are so bizarre they defy all logic of self-interest. It's that moment when the instinct of fatherhood and the survival of the species rise above a living creature's most basic needs: the drive for food and the will to stay alive. The ultimate husband, the dream of human female. While most bird species across the globe share the duty of incubating eggs or dump the responsibility entirely on the female, the emperor penguin flips the script as brutally as possible. The journey begins precisely when the Antarctic winter sets in. After the female lays a single egg, an effort that drains almost every last drop of her energy reserves, she is completely spent. She must immediately trek back to the sea, hundreds of miles away, just to feed and survive. At this moment, the weight of the next generation falls squarely on the father's feet. And you didn't mishear that. It's feet, literally, because in this frozen wasteland, there are no nests, no twigs, and no straw. The father has to delicately use his beak to nudge the egg onto the tops of his feet, tucking it under a thick fold of belly skin, packed with fat and dilated blood vessels designed to radiate heat. This is a high-stakes balancing act. If that egg touches the ice for even a few seconds in negative 40 degrees Celsius temperatures, the embryo inside freezes, and life ends instantly. This is where the extraordinary begins. The father stands there like a living statue for 60 to 70 days and nights in the pitch-black Antarctic winter. During this entire stretch, he eats absolutely nothing. Surviving solely on the layers of body fat he spent the entire summer stocking up on. To survive blizzards that can flash freeze any living creature, and cold so intense it could topple the fiercest predators, thousands of fathers form a unique social structure called a huddle. This is essentially a massive, collective heating machine. They don't just stand side by side, they move in a highly organized rotation. Those on the outer rim, battered by the freezing winds, are gradually pushed toward the warm center where temperatures can soar to 37 degrees Celsius, even when it's negative 60 degrees Celsius outside. Once those in the center have warmed up and recovered, they voluntarily move back to the perimeter to shield their exhausted comrades. It is a perfect system of cooperation, where individual selfishness would mean death for the entire group. When the chick finally hatches, if the mother hasn't made it back with food yet, the father pulls off one last biological miracle. He secretes a special milk from his esophagus, a curd-like substance packed with protein and fat to nourish his baby. He does this despite having lost nearly half his body weight and standing on the brink of total collapse. The moment the mother returns with a belly full of fish and squid, a sacred handoff occurs. Only then, after more than 4 months of starvation and guarding his treasure in the middle of a frozen hell, does the father waddle toward the sea, his steps shaky, but his spirit triumphant. The image of these ultimate dads is more than just a touching story of fatherhood. It is the most powerful evidence that evolution has forged a will of iron that transcends normal biological limits. What we see here is a flawless integration of specialized anatomy and a sophisticated social behavior system. Penguins didn't just adapt with their flesh and bones, they adapted with a collective psychology. Looking back at this entire journey, from their rock-solid bones that conquer oceanic pressure and the genius countercurrent heat exchange system that guards every drop of energy, to their flat eyes that pierce the underwater gloom and the brutal, sacrificial instinct of fatherhood, it becomes clear that absolutely nothing about a penguin is normal by the standards of the terrestrial world. They aren't failures of the sky or clumsy creatures left behind by evolution. On the contrary, they are some of the greatest conquerors on Earth, pioneers who chose a distinct, grueling path to survive and shine, where almost all other life would simply surrender. The strangeness of the penguin is more than just a fun biological topic for casual conversation. It is an eternal anthem of absolute adaptation, a reminder that life always finds a way, even in the harshest conditions. As long as we have enough weight to dive deep and enough solidarity to weather the blizzards of life. Is the above interesting information about penguins enough for you to recognize that they are strange animals? We'd love to hear your thoughts in the comments below. Also, don't forget to suggest any topics you're curious about, whether it's more secrets of the natural world or the amazing creatures all around us. We'll continue our journey in the next videos. Goodbye for now, and remember to cherish and protect nature, my friend.